So the reason I'm starting with arrays is because that's the only place where we have to have consensus. So I'm kind of driving this in terms of dependencies. So all of our smart contracts effectively look like things like this, right? And this is where we can possibly have non-determinism. And so this non-determinism drives consensus. Yes?
So what about smart contracts for, say, web server? How does the contract prove that it has issued the correct page as opposed to merely serving up garbage? Right? If there's anything off-chain that the contract has to interact with, it's not merely getting consensus on channels, but getting consensus that the thing had.
Out to the fringe. Right? So you're going to have to trust whatever validators on that namespace that, it's like, if it's not on chain, it's not our problem.
So one thing that came to mind was any content that got served up would have to be signed in a way that could be verified that it was, that sort of thing.
Yeah, exactly. I mean, so one of the things that Mike is pointing to, and this is going to show up in the architecture discussion, and should show up right away. And so let me just draw over here for a second. So everyone, where's the bulk of you? I think I should probably stand this way. Okay, so down here we have the JVM, and above that we have Scala, and the Rholang compiler sits up here. So this Rholang doesn't know anything about consensus, nothing at all, right? So you could easily write web server applications using this approach. Now, what we're going to do is to add Casper up here on top of Rholang. So Casper is written entirely as Rholang protocols, right? And the advantage of doing that is that once the type checker is implemented, we type check all of these. And the type check becomes our first order proof of correctness. Now, there may be a lot more details that we want to prove correct, but this is our first order proof of correctness. Once you have Casper, that gives you a new notion of port, right? So this is port as address on the blockchain that's implementable using this consensus. So down here, we have a bunch of notions of port that are natively available through this binding here. Like a TCP port, like an HTTP listener, right? An HTTP connection, an MSMQ or RabbitMQ queue, an SMTP mailbox. All of those things can be mapped very nicely onto the notion of port. And I know that that's true because that's exactly what we did in BizTalk. So at industrial scale inside Microsoft. So that's a given, right? And the only thing we're doing now is to expand that notion up this way, right? So that's the key idea, and then all you're really doing is opening the door to a bunch more ports. And these are new types of ports. And this shows how, in general, we do system integration. So that's why I'm leading with Rholang, because Rholang drives the entire architecture. Is this making sense to people? Yes?
Might be worth drawing another Rholang box there on top of Casper, the stuff that's running on the blockchain.
Yeah, exactly. So what we're going to do in this discussion, or Rholang plus blockchain or whatever, Rhoblock. Yeah, well, essentially, it's the same Rholang, but now you have new types of ports, right? And so I'm going to simultaneously go back and forth between the language design problem and the architecture problem. And I'm making a bigger point here, which is that language design and architecture go hand in hand. There's kind of a reason why C and Unix grew up together. They really, really do go hand in hand. The same is true of CLR and C#, right? The same is true of Java and the whole Java ecosystem. Language design is at the heart of each of these kinds of architectures, right? And each language architecture gives you a world to look at, or a world, a point of view through which you look at the world.
At some point, and I suppose this is going to come along, you're going to talk about tokenization in the language.
Yeah.
Not coin tokens, but token.
Yeah.
Yeah. Because that's going to be key. I'm curious if there are other languages that implement that in their own.
Yeah. Please repeat the question into the mic. Because it's a really important one.
Yeah. At some point, are you going to talk about tokenization in Rholang? Because those are foundational constructs, and they exist in other languages, and it's going to be really important as to how people build things.
You're absolutely right. So in terms of our really, really crude block diagram structure here, there are two places you can put tokens. There's got to be more than just one person in the room who can spot those. What are the two places? Not you.
Just to clarify, because the question you said not coin tokens. Are we talking like tokens that you are using in Alexa?
That's what I meant. Yeah.
Oh, you mean tokenization in terms of the
Tokenization in terms of the language.
Oh, yeah. That's just parser stuff down here. That's really, yeah.
And to further clarify the question, are you talking about tokenizing Rholang itself, or writing a tokenizer for another language in Rholang?
No, how Rholang is going to be tokenized, because the concepts you're talking about, right? Those atomic things speed up the language.
So if you want to look at that, that opens up a really, really good set of questions, and let's go down that path just for a second, and then come back to the what I thought you meant by tokenization. Thank you, good catch. First of all, we're using a tool called BNFC, which allows you to easily construct, and we also use Antler as well. Excellent. I love your wry smile. That's awesome. Tim has some very, very specific opinions about BNFC. So we should definitely get into that. So I've used BNFC for a number of years, and I'm happy with it because it provides a meta level for all of this. So I'll just draw this here for a minute. So BNFC, and we can think of Antler as essentially a sister to BNFC. They fill roughly the same positions in the ecosystem. BNFC allows you to describe at a very high level the grammar for your language and the tokens out of which your parser is built. But it's a parser generator. So it hits against CUP, which is the Java ecosystem, Flex and Bison, Happy and Alex, and a bunch of others. So this is so for those people who are not like language wonks, this is the Java ecosystem. This is the C, C++ ecosystem. This is the Haskell ecosystem. OCaml is, oh God, it's escaping me now. Anyway, what's that? Anyway, so you write your language here. So we have a Rholang grammar for BNFC, and then we can auto-generate for each of these. And similarly, Antler gives us coverage of things that BNFC doesn't. So if you, yes?
So my understanding, you just told me this is correct, what it auto-generates is types for the AST in each language, and Java is the one we're using, and then a lexer and a parser to go from
That's right.
straight code to
Yeah.
the AST.
It also auto-generates kind of crappy, sucky Walker. It gives you another layer of toolage, so it generates a visitor pattern in the case of Java. So those aren't particularly. I've used them a couple of times, but they're really, really inefficient and ineffective.
I have some questions about this, but it can totally wait.
Yeah, absolutely. So Lawrence, hopefully this gives you a sense.
No, I didn't want to get too deep into it, but that is, exactly what I.
Okay, cool. All right. So I would like to look at the other thing because it's very, very closely related to our goals with respect to Mercury as well. There are two places we can and have to put tokens. Where do they live? Not you.
But it's the only question I can answer.
Yes, please.
So you'll need tokens at a minimum in the Casper level, so for staking.
Yes. Okay. So
otherwise
staking
you can't
tokens.
do it.
Yes. So really, it lives. It's a part of Casper. Yes, that's correct. So staking tokens. Anywhere else?
Presumably contracts, right?
Well, yes. So you can also put ERC20-like tokens. ERC20-like token contracts up here. Right? So this is where apps will generally make their tokens, right? And this is where new communities who want new RChains with new staking tokens will introduce their tokens.
Are you considering phlogiston?
No. Phlogiston is calculated. But that question ties between the two questions, right? So there's this question of how to calculate phlogiston and how that relates to the parser, right? Because at a minimum, we need to be able to give people estimates for the rev they're going to spend, and then we need to also at runtime spin that out, right? Or spin the phlogiston out. So, thank you. All those questions are driving our picture.
Did we get the second answer?
I think we did, but let's double check. So make sure I've understood your second answer question. So we're talking about, yes?
To clarify, the Casper staking token is an alternative token for staking, or is it REV? Is that the token you mean?
That's REV currently.
Okay, so that's the currency of whatever blockchain we're building this instance of RChain.
That's correct.
Anyone who wants to fork another one.
Right, but there was a huge question about alternative staking tokens
At the
member meeting, and the terminology is a little smushed, right?
So the ERC20-like tokens is the second answer.
The ERC20-like tokens is the other answer. That's right. Yeah. Okay. Cool. So yeah, actually, let's get really crisp and clear on that because we need to be able to talk to community members with solid understanding of what we're talking about here. So, in order for Casper to work, you have to have a staking token. That's what Casper does, right? And that has to be below our blockchain implementation, or the Rholang++, right? This is how we implement the blockchain. So these tokens kind of live down here. They can be written in terms of Rholang, but they live down below what Ethereum thinks of as smart contracts.
So we're thinking of Rholang as like an intermediate language, and Rholang is the
High-level
user
language. Yeah, exactly. And the only difference, and that's where I was going to drive next, the only difference is how this is parameterized on the ports.
Okay.
Okay? So that's why it's really, really important to understand. The other thing is, as Kent has pointed out several times, we will get, in order to avoid double spend, you have essentially rev gets linked into every transaction tangle. Once you have rev linked into every transaction tangle, then you're lowering the total amount of concurrency you get. Right? You can still get concurrency, but it's not nearly as much as when you have multiple staking tokens. Because then you can literally get validators in one namespace and validators in another namespace, and they don't have to synchronize at all. And you don't have double spend.
Okay. I think I'm still a little bit fuzzy on the terminology here. So the Etherium analog is Ether, right? But this is being extended in RChain, possibly in the future, to include different staking tokens.
That's correct.
Is that on different chains, or is that, because my impression was that was on the main RChain chain. And that was why people were maybe reluctant to pull the trigger on that in the meeting.
Yeah, so the most wonderful thing is what constitutes the main chain.
Right, we'll talk about that at some point.
Yeah, so I want to argue that in fact, just in the same way the existing economy works, right? If you forced all of China to suddenly use the US dollar, you're going to slow down a bunch of transactions, right? The reason those transactions can go forward is because you have different networks managing the different resource distributions. And so there isn't ever going to be, if we have a healthy economy, there isn't ever going to be a main chain. If you have a main chain, that means you have one record for that main chain. And once you have one record for that main chain, you have to download that record for main chain for everyone to synchronize. And we're already beginning to see situations where it's possible for people to never be able to catch up.
The Rev chain.
Right. Rev chain I like. Okay. That's very specific and clear. Yeah.
So what sort of fungibility do we desire between each sister coin? I imagine that users are going to want to swap out Rev I for Rev J.
Yeah.
And do we need to ensure that each sister coin maintains a price that's consistent with every other? So do we need to synchronize the prices? Or,
right.
or
yeah.
would that be specific to the coin?
That's fantastic. I love this question because, one, in order to get this off the ground, I think we have to protect the rev for a period of time, whatever it is, a year, 18 months, whatever it is. We just have to get it off the ground. Once it's off the ground, that's really policy that's set by the various decentralized parties, right? Maybe there's a, the red RChain co-op and the blue RChain co-op, right? And now they have policies about their staking tokens. And then because everybody's sharing exactly the same infrastructure, being able to build bridges is now trivial. Right?
So I could choose, living in a certain namespace, the amount of variation which my coin takes from the original Rev or to any other sister coin of Rev.
That's right. And and I really want market forces to let that dominate. And at the core of it, right, the market, go ahead.
What he said and what you just said are not the same thing.
Okay, so
He
what?
said I could choose, and you said market forces.
So me being a part of the market.
I think choice is at the underlying market forces. That's how market forces get expressed. A bunch of agents express choice.
But not the developer.
No. Market forces.
I mean, me as a user.
Yes. Yeah. Good catch.
Not as a developer.
Good catch. And that's great. That's fantastic. Thank you. Yeah. Good.
The traditional way you have, let's say, free floating currencies against each other, and then one currency is for, let's say, a small country, and they want to say that our currency is pegged to the dollar.
Yeah.
So it would be like that, and then you would, as someone developing a sister coin, you would be like, okay, how does a currency board in a small country do that? What they usually do is have it be convertible on demand into the base currency, and you could do the same sort of system in a sister currency on the same RChain.
Right. So and a certain amount of arbitrage between the two coins. So I guess the ultimate question would be, if we want to be able to exchange sister coins for each other, who manages the exchange infrastructure?
Yeah. And my hope is that that's a vibrant market, that there's lots of competition on exactly that, just as it's emerging right now between Ethereum and Bitcoin, right? There are these particular integration technologies, and what we're trying to do is to make it so that this is also the integration technology that makes it possible for people to cooperate and compete over exactly that. Yeah. Did you have a point? Okay, all right. So great. This is what it should be round table. We're all discussing here, and we're just driving it from various points of view. But that discussion brings up something that's what makes this space so attractive to me, is that when we talk about the RChain architecture, it's impossible to separate the technical architecture from the economic architecture from the governance architecture. They're all interlinked in this crazy way. And if we don't recognize that, then we build a broken system. So when we're thinking about the RChain architecture, it's really interesting, isn't it? I mean, this is what's so exciting about this space. I've never really had when I was building BizTalk, I had visions of what this might do in terms of market architecture, economic architecture, and labor architecture, but that wasn't the same kind of reality as it is here. If we get the governance wrong here, it doesn't matter how clever this is, right? People will just walk away, right? If we get the economic architecture wrong, it doesn't matter that this could have supported the right economic architecture because people just won't use it, right? So this is the triangle that I keep in my head all the time, right? There's the technical architecture, the governance architecture, and the economic architecture. And that's effectively what we're designing, and I hope that everyone, like me, is keeping that in the back of their heads as they're doing this. Just like they're keeping, what drives Mercury in the back of their heads even when they're writing individual lines of code. Okay, cool. So let's take a look. So now I want to do a little bit, go ahead.
Before we move away from that point, I just wanted to make sure I understood what you were saying about new types of ports. Are you saying that Rholang channels are new kinds of ports? Was that the point?
That's right. Yeah,
okay, just wanted to clarify.
No, thank you. Good question. Very good question. So that actually sets up the next thing, right? So probably a bunch of people have seen me write this, but I'm going to write it again, and maybe we'll write it 100 more times. So when I think about Rholang or the pi calculus, I'm thinking about a data type. P. I'm just going to use a single letter so I don't run out of space here. Right, but it's a data type, and the data type is parametric. And it's parametric in the notion of port. I'll call that X. Okay? So this is just like I was writing a Java type that's parametric in X. Okay? And now what I'm going to do is I'm going to give you each of the different case classes or however you want, specializations of this particular type. So when, and this shows the sort of the general shape. When I write a grammar, the non-terminal symbols you could think of as abstract classes or traits in Scala. They're interfaces sometimes. And then the things over here are more concrete. They might be case classes or something else, right? So this thing that's parametric in the kind of type is going to, the first one is just, we're going to get off the ground, right? So this is, if we were thinking about this in Scala, this would be a case object, call it 0, right? In Java, this would be some kind of singleton class, right? So, and intuitively, this represents our stopped process. Doesn't do anything. And then the next one is input guarded I/O. All right, so we wait, and I'll just do this. Well, no, I'll do it more generally. So it's Y1 from X1, yada yada. Yn from Xn, P. And it's that P there, and so it has to be parameterized in X. Okay? And then output guarded, oops. And here, again, it's that one. Whoa. So those are the recursive ones. And then now, the one that's really nice, well, so let me do parallel composition. Right?
Do you want to enumerate those, just so it's clear that they're separate?
Okay. No, not in this format. Right. Normally, if I do that, I'll do something like this: P comma Q, and I get onto the left, which is non-standard, but it's adopted by researchers like Luis Cares and others. This is non-standard for these kinds of things, and sometimes it throws people who are knowledgeable about these off to use this form. When I do the parametric form, it becomes even more cumbersome, because what I'd have to do is I'd have to do P, X, Q, X, and suddenly very cumbersome. And so that's why I'm not doing it here. Yeah. But good question. Yes?
And also, this is more in line with mathematical notation if you're representing this as a polynomial, say.
Yeah, exactly.
Combinatorial.
Yeah.
Oh,
yeah. So Mike was saying that this is more in line with a mathematical notation. Like this would be like a polynomial notation. And so I've been driving this from the point of view of from the point of view of programming language intuitions, because most of us here are developers. I'll also do the same thing the other way, which is to go from the math, and so you get the thread all the way through. So math, program, and sort of operational semantics style, programming language theory style. So there's one more case, which is at X. Okay, and that's it. That's all the forms, nothing else. Now notice X comes in from here, right? So this is, yes? Nothing else for row calculus. And because I'm doing, you know, because we're at the board and we're trying to get through everything, I'm not going to go through all of the syntax of Rholang in this session. I'm just so now what I'm going to show you is a trick. Okay? So the first trick, notice that this is parametric in X. So I could do the following knot tying. So here's the trick. I say RP, so that P there, and this R stands for reflective, is going to be equal to P of RP. There. That's the row calculus. It just pops out as a solution to this recursive equation, which is specified here. And then it turns out that we know that this recursive equation has a solution because we know some things about these kinds of grammars.
You're looking for the least fixed point.
Yeah, you're looking for the least fixed point. Actually, there are lots of fixed points. You could go get the max fixed point. Yeah, but the least fixed point is the one that's sweet here. Good morning. You walked in at just the right time. It was perfect timing. Okay, but this system, from the point of view of practical architecture, is not practical. Because every single channel is a what? It's a process. right?
Quoted one anyway.
A quoted one, yeah. Every single channel. And notice that this system actually gets off the ground. Why? Because we included a 0. So the very first name would be, you know, at 0. Is that making sense to everyone? Is everyone following? Don't nod your head if you're not. You know, let's drag this beast to the ground. Yes.
I would say that it differs from how I've seen the calculus presented before because it doesn't include a drop operator.
Sorry, yes. Thank you. That was just a
Oh,
type.
it shouldn't be at X, should it? It should be at P.
No, yeah, it should be at P and star X. Thank you.
X, yeah.
Thank you, yes. Star X. Good.
At P of X.
Yes, thank you. There we go. Yeah, so those are the cases. Thank you. Good job. And now this is RP is equal to P of RP. Cool. Okay, so now, just briefly, I'll quickly do the math equation that goes with this. And you can, again, you can just read these out. These, by the way, are X's. So if I'm being really, really careful, that's an X, and that's an X. And I wrote these in to shore up your intuitions, but if I was being super, super careful so this got through a parser, I'd have to do that.
Yeah, so just by the way, the last two sets of changes actually make this a lot clearer.
Yay!
So the not being precise doesn't help understanding.
For you. Yeah, for other people it actually does, but yeah. But good, very good. Thank you for that comment. I appreciate that. All right, and so there's our more precise formulation of the data type for processes. Now that data type can be turned into an equation, which is Mike was talking about. So this is equal to 1, so that's this thing. In sets, you can think of this as the set with just one element, right? Or, so each of these or cases becomes a sum, right? Or, and now what this is a list of pairs, okay? So we have X cross X star, that's as many as you want there, cross P of X. Okay? This case is that one. This case is that one. This one, someone read it out for me. What is it?
X times.
Yes. X times P of X plus, yes. So, and then to be really, really pedantic, right, 2P of X is the same as P of X cross P of X. Okay? All right? This one is just P of X, and this one is X. There, that's our domain equation. And that domain, and having that domain equation in this particular form is what lets us know that this equation is solvable. And that's how you find the row calculus. Okay, now, so what we've done is we've presented a grammar that is close enough to what you could feed into B and FC to generate Scala classes or Java classes or what have you. And we've shown that that grammar is an completely isomorphic to the domain equation, okay? But now we want to drive the other way, so we've been trying to make contact with the developer side, and ultimately we're going to try to make contact all the way out to here, right? So the first thing we want to note that was brought up by Nash is there's a bunch of different things that could stand for ports over here, not just these funny quoted processes. Okay, so let's list some of these out just to try to be clear about that. So TCP, UDP, HTTP, SMTP,
storage line.
file, yeah, storage of some kind. Okay, so these are all ports, right? And those are all practical ports. So notice that this was just one particular solution or formulation of this very generic equation. So I could do this. I could make this practical. So let's call it real world processes, okay? And those are going to be P of the real world processes, so that's the quoted case, plus now each of these. Okay? Yeah, plus whatever your ports are. Yes?
So I have a idiotic question, just going back to the really old school use of the ports that you've got there. So the non-symbolically defined ports and limits in the OS on the use of those ports cause huge problems in old school days. Like you can only have so many listeners on a TCP port, so you have. Is that not an issue here, or is the mechanism for addressing it, or what's?
No, it is absolutely an issue, and the mechanism for addressing it, first of all, is that rather than lumping these all under ports, remember, this ports is broken down into this list, and each one of these is a different kind of port. So you get type-level information about exactly those characteristics with respect to usage limitations. Yes?
And StarX only works on specific types.
Only works on specific types, that's right. Yeah, exactly right. So you get type-level information on the usage of each of these ports that correspond to their native limitations. So,
okay, so there's a type-level information that is solving the old namespace that resolved by knowing people knew that.
That's
port
right.
31 was whatever.
Yeah. And then the next piece of the puzzle. So everyone can reproduce this race, right? The next piece of the puzzle is that you have port-level adapters that are provided by the compiler for each different kind of port. So that's the piece of the puzzle that's missing right here. So the piece of the puzzle that we introduce, and this is what Kent has been working on for the last couple of weeks, is refining our tuple space implementation, which is providing the adapter layer for each of these different ports. And this, by the way, is exactly what we did in BizTalk. Precisely what we did. And we knew that, actually, with BizTalk, here's the strategy that I use for the market. I didn't pick the port types behind which most enterprise data lay. Because if I had done that, it would have been completely skewed towards older technologies, because that's where all the data was, right? The data had been collected. So if I'd done that, I would have gone against particular database types. I would have gone against email systems, and I would have gone against certain messaging systems that were all considered legacy by the market at the time. Instead, the first port types that we provided were COM, because it was Microsoft, right? Microsoft Message Queue, right? And I can't even remember what the third one was right now off the top of my head. But they were all forward-looking port types in terms of forward-looking technologies, and we were explicit that we were going to Tom Sawyer the rest of the market into providing these. Why? Because this is where the bulk of the work was. Right? So it becomes this vibrant consulting arrangement, right? Professional services kind of gig to integrate into BizTalk via these ports. Is this making sense to people? Cool. Go ahead.
In order to make the blockchain work, we, however, are going to have to do at least TCP or UDP,
yeah,
and the storage layer and that sort of thing. We can't Tom Sawyer
no,
much of that away.
No, you're absolutely right. So we're not so that is exactly driving to the next point, which is how do we drive out our architecture? So let's draw the Mercury thing, right? So I've got this stack over here, which is, you know, JVM at the bottom.
Do you want to put Rosette into that somewhere?
Yeah. Rosette. Rholang. Yeah. Yeah, that's right. And then up here we have.
Yeah, the Rholang compiles to RBL, which is run in a Scala-based VM.
Of course, I always make the JVM too big. So let's do this again. Yeah. So we have JVM, Scala, Rosette, Rholang, Casper, Rholang, ERC20. God, this looks ridiculously fat, doesn't it? I just can't wait till we can cut out this and have our own native virtual machine. Right. So this is our token and wallet. Okay, so this is a proxy for token plus wallet contracts. Right, and that lives inside some container which is connected via the wild and woolly internet to some other container that does the same thing. It's got at least that much. Okay, so over here we have JVM, we have Scala, we have Rosette, we have Rholang, Casper, Rholang, and the ERC20.
So are we kind of mixing up the layers that are part of the tool chain with layers that end up in the architecture, right? Because Scala isn't part of the architecture.
And the thing is that it actually influences
Well,
huge amounts of architectural choices.
Where I was going with it is it's not as fat as it looks, right? Because some of those don't survive, right? Scala may influence how we did a bunch of things, but it's not part of the result.
Yeah, you're absolutely right. So what should happen is that, you know, if we've done our job well, you know, we can kind of insulate at this layer, right?
Goes away as well.
Right. Yeah. Exactly. And we can insulate against this layer, right? Right. So if we've done our job well, and Scala has tried very hard to do that. I don't think they did it. I don't think it's practically realized yet. I think the Scala LLVM compiler, for example, is still languishing. Oh yeah. That is pretty good actually. We use Scala.js quite a bit. Yes. Oh, you're just getting comfortable. Okay. All right. Okay. So this is the minimum architecture that we have to get to, right? With there being, you know, lots of these and lots of these, right? Hundreds of these at a minimum. Is that making sense to people? So it's not necessarily different machines. You could have a giant server that's got a bunch of containers like this running on top of it.
Yeah. So these are nodes.
These are nodes.
I was surprised that you didn't have anything above the. Well, maybe it's the top Rholang or the Rholang ++ that, as a minimal node, there has to be interface stuff.
That's
in that upper layer somewhere.
That's correct.
And can you elaborate a little bit more about? You were saying that the bottom Rholang and the top Rholang, the difference is the ports and the way the ports are either blockchain aware on the top one.
Yeah.
Are the actual language constructs or the libraries or what makes the top one different from a compiler perspective?
Yeah, so the only difference from the language point of view is that they have different types. right? That's it. And that was the whole point of this whole digression right here.
Okay, thank you.
You don't change anything.
There's some additional types.
And in particular, at the top level, you're not going to have direct access to port style names. At the top level, you're only communicating on blockchain names. It's only the system contracts on the lower Rholang that need to talk over the network. Everything else happens as part of the blockchain.
And in fact,
I want to dive in on that for just a second. I believe there's going to be a very vibrant market around oracles. And those oracles are going to be contracts that bridge both worlds. Yeah, exactly.
Yep. So
what? Thank you.
Okay, so so the types, you have more types available on the top one, and it seems like the corollary to add what Mike was saying is perhaps the top one, and certainly user contracts in general wouldn't be talking to things like the file system. And so some ports would be off limits.
No, that's what I just said. None of those things in the ports list are available at the top level.
Yes, right. So I was just
through Oracle.
Confirming that. Okay, my understanding.
So there's actually a reconciliation between your question, more or fewer types, right?
Different types.
Yeah. Well, no. But because what Mike is saying is actually shrinking the type space. So. Yeah.
Well, but then it has Casper, so it has different types.
Well, but really, from the point of view of the average smart contract writer,
right?
They're writing against ports that go against the blockchain.
Correct.
So from their point of view, there's only one type of port. I mean, maybe they're looking at usage types, or they're looking at behavioral types, but in terms of where the rubber meets the road,
got it.
Right? There's one type of port. So the total spread here got shrunk down, except when you're writing oracles.
Okay, so these in essence are two different Rholangs, and it seems like we need more clear language around Rholang lower and Rholang upper.
We have taken to calling the lower one system contracts and the other one's user contracts.
Yeah.
Okay, but what I'm hearing as well is that the compiler capabilities are different as well. Is that not true?
No. And the upper one has no view of Casper. Casper is something that is written on this. There are system contracts for implementing Casper, but the upper level compiles down to stuff that uses Casper. It's not visible to the user contracts.
So,
any more than JVM internals are visible to someone writing Scala.
Exactly.
Right.
Okay, there's a different compiler environment then, or different libraries that are linked, or what's the right?
Yes, different libraries that are linked. That's correct.
Okay, thank you.
Yes.
Earlier you said that the compiler has support for the different kinds of ports.
Yes, but notice that once you've got a certain amount of communication infrastructure, you can always build new ports that use lots of ports underneath, right? And that doesn't change the language design. It doesn't change the compiler.
Okay, hold on. Does it change the compiler or not? Because I'm hearing both sides.
No.
Earlier I heard you say the compiler has support for each type of port.
Right, but here.
So that changes the compiler.
This ground where the rubber meets the road kinds of things changes the compiler. Not really, because we hide that all underneath the tuple space. We write adapters, and then the compiler targets the tuple space as a uniform layer that all ports have to support.
My current design for how this is going to work is that you will not be able to do foreign function interface stuff from Rholang, but rather only from RBL. And you will write a small thing that I'm calling a power box in RBL that exposes all of these kinds of ports as Rholang channels, or at least the same sort of thing that Rholang channels get compiled into, which are actors in Rosette. So they'll provide actors to which you can send messages using Rholang syntax, but you never get direct access to the ports themselves from Rholang. Now, Greg may have a different idea, but that's what I had thought of.
There are a range of possible architectures here, and we're as we dive into this, what we're going to discover is there's some market forces are going to create value for different variations. And that's totally cool. But I want to get to something that you're just tugging on that's actually quite important and very fundamental.
I just wanted to add my justification for that.
Yeah, sure.
Which is the object capability discipline
Yes.
of we don't want user scripts, user contracts to be able to get direct access to these ports because they're far too powerful.
Yeah.
You want to be able to you want to be able to reason about the bounds of the authority. What can this thing do given the names that it receives, rather than having all of these things ambiently available.
Yeah.
So the job of the power box is to attenuate and delegate the authority that these ports provide to the system contracts that need those. And so even the system contracts won't have access to everything, just the stuff they need.
So that's a great point. Can you talk about oracles in relationship to that?
Oracles are going to be effectively user-authored system contracts. They'll be running on the blockchain, but
they speak both sides.
Yeah, this Oracle idea was something I haven't considered in depth yet. So maybe Greg can speak more to that.
So, yeah. So essentially, and this is what I was just about to drive at with notation, right? So first, I want to create a place where we can hang our thoughts, and then connect that to the bits that have to move around, shuffle around. So notice that in order for P, one of these things, to talk to Q at all, they have to have a channel that they share. Okay? Now, notice that I could refine this, and I could say, how about I do this? I have some C, which has an X and a Y, and then P is talking in terms of X to C, who is talking in terms of Y to Q. Does that make sense? Okay, so this is still all within this framework here. This is a user-level written thing. This is a Rholang written thing that is essentially establishing a contract that is serving in the role of a channel from the perspective of P and Q. Does that make sense? Okay, so this thing might be a system contract that has access to low-level stuff. This thing might be a user-level contract that is all blockchain-oriented, but it needs access to information. And now C is providing that layer in between. So this is where there will be lots of market value. I need to read off this ticker feed that's not being stored on the blockchain. Or I need to create a blockchain version of this data. Right? That's what these kinds of things are going to do. This is going to be huge. Why? Because most of the data is not on the blockchain.
So I guess there are two ways of approaching that. One is if if a validator is running a node, they can choose to add new ports for ticker feeds and so on and write a system contract that exposes that.
That's right.
Another way is to come up with a principled way of exposing these ports actually to things on the blockchain. And we can discuss what the...
Exactly, and I have a feeling that for some period of time we want it to be kind of loose and let the market kind of go, this is painful, this is painful, this is painful. Here's some balm for that pain. Okay, so are we making people feel good about? Okay, awesome. All right.
One thing that I'm quite unclear about is what tuple spaces are, but I assume we're getting to that.
Yeah, we're yeah.
So P's got to be written in the software, and Q's got to be written down below.
They're both. P is written in this carving up of things. P is written here, right, and talks to C, which is written here and here, which talks to Q, which is written here.
So how does C generate consistent view of Q for Q so that you can have consensus on
Yeah, so that's entirely inside C. That's specific logic for specific data sources. There's nothing that we can provide that's generic here. Yeah. Yes?
Before we go on from our picture of a node, can you speak to what Rosette is and why it's there? Because as far as I can tell so far, it's just kind of been tacked in. It's like, oh, and also there's Rosette.
No, that's very good. Thank you. So I'll drive that way before moving to the next topic. All right, so I can get rid of this. And what it has to do with is we want some kind of virtualization of the hardware. Yes?
One more question about the thing you just. What kind of Oracle stuff is there that you can't do on the user level contracts? Just as an example, because.
Well, I mean, web data sources, web information sources, they're not on the blockchain. And there's,
AWS.
yeah, exactly. Anything that's the external world that's not on the blockchain. Yeah.
Fair enough.
In other words, 99.9% of the internet.
Why do they call them oracles instead of sensors? Is beyond me, but I haven't.
Because that's what the blockchain space called them. You could also call them transducers. I mean, there's just like there's a wide range of control theory terminology for exactly this stuff.
So can we think of an oracle as always being a port to something that's outside the blockchain?
That's a generic description, but you might be, like in a lot of applications, probably what you'll be doing is combining, aggregating some feeds. So it's not just a port, it's doing other stuff.
Right.
Like in the standard data pipeline stuff, you'll be aggregating, cleaning, normalizing, processing, right? That's your standard big data application, right?
Does it make sense to talk about an oracle that only operates on data within the blockchain?
I wouldn't use Oracle for that.
For that term? Okay.
Yeah, maybe that might make sense at some other point, but yeah.
Got it.
So one of the things you've been talking about is a possible solution space is oracles that just take data from the blockchain, because blockchains are inherently transactions, and transactions in the real world always go with analytics processing, and that's an open space for either RChain or some third-party provider to provide value.
Yeah, so I'm fully expecting there to be tons and tons of blockchain analytics. We're just barely at the beginning of tapping into blockchain analytics. I mean, blockchain analytics is going to, I mean, if you think about it, right, if more and more and more of people's choices in aggregate are going to be recorded as transactions on the blockchain, then this gives you this very, very fine-grained, detailed view of collective behavior. It's a little scary, but that's exactly what it does. And so providing analytics on top of that, you know, it's like way more important than providing analytics on top of Twitter or, you know, Facebook feeds or things like that. It's way, way more important because you're seeing people's choices with respect to transactional behavior. So yeah. Okay, now to your question. Sorry, you were so patient. Thank you. Okay, so we want to virtualize the hardware, and if LLVM had a good concurrency story, I would have gone to LLVM.
Sorry, what's LLVM?
Think of LLVM as a virtualization of the hardware. It's lower level than JVM, right? And I would have targeted that had it had a good concurrency story. It does have a concurrency story, but the granularity is wrong, and the model is not specified well enough So essentially, in order to really get down to the details, you have to be talking to an expert immediately, and that's not scalable. So I said, do I have a virtual machine that already has a good concurrency story? Well, yeah, I do. I have this actor-based virtual machine that I built in the 80s with Christine Tomlinson and Mark Scavell and Greg Lavender and a bunch of other luminaries in the CS and distributed computing world. And we used it to build out things like ATM network management systems for NCR, Sumitomo, TSB, and a bunch of others. We did data cleaning applications for Belcore. We did data integration for Eastman Chemical, a bunch of industrial applications. So I knew that this worked at industrial scale. I could actually, build stuff where, I was on the hook personally to banks for their physical infrastructure. So I knew that it worked in that setting. So it wasn't like the EVM, which was just like grown out of thin air and not bashed on by industrial level applications. So it represents an abstraction that ultimately, if we could get rid of at least this layer all the way down to the hardware, we can write a compiler from the Rosette VM or some variant thereof straight to the hardware and have a concurrency story, so we don't have to implement the concurrency story from here to here. Is that making sense?
So Rosette is really the VM that we're targeting, and the Scala JVM stuff is just because there's currently no good way of turning Rosette into instructions for a processor.
Yeah, or it's not that there's no good way, it's that that's costly and expensive, and person power expensive. It's not just capital expensive. You have to have the right expertise, and if you blow that first year, you're done, you're toast. Here, there's so many developers, so many tools, and we can get to market faster with something that we know will work.
Okay, so then the idea is that converting Rosette into Scala is easier than converting Rosette into machine instruction. Is that?
That's correct. That's right. Right. And also what we're doing is it's part of team architecture. So there's a fourth architectural thing, which is community architecture, and that's somewhat different. We're trying to educate people on each of these different ways of notions of computing. Right now, in terms of the balls we've got in the air, right? We've got an actor model of computation, we've got a process model of computation, and we've got the blockchain's perspective on computation and consensus. So we've got at least 3 balls in the air, right? And that's really going to, that's why we're having these kinds of retreats, is to get everyone sort of being able to keep all those balls in the air, right? To think in terms of each one of those and be able to communicate across those different concept spaces.
What was the middle one, actor?
So there's the actor, process, and blockchain plus consensus.
So in an ideal world, if you had, infinite manpower and expertise available to you, you would want process everywhere.
Straight down to the metal.
Okay.
Yeah.
And is that an ultimate goal?
Yes.
So
that's part of our mobile strategy.
Okay. Okay, cool.
Yeah, yeah. So, and again, this is not just like pie in the sky, ha ha ha. Pun absolutely intended. In 2002, Satnam Singh, who I had hired away from Xilinx, he was the CTO of Xilinx. I hired him out of Xilinx into Microsoft, into our process calculus project. Jan Gray, who is a well-known hardware engineer, and Alan Brown, who's a well-known logician, and I, Bill tapped us to write a Think Week paper on what we were doing, and what we did was to write a compiler from, at that time, just straight up Pi to FPGA. So we already know how to go straight against the metal. Okay, we really want to do this. It raises all kinds of cool and interesting questions. Really, really cool questions. So here, just for fun, just to tantalize you a little bit, Satnam, being the genius that he is, he says, all right, here's my surface. My pi chip takes up this much. I'm just going to tile the surface. Okay? So immediately, just out of the box, just right out of the gate, we have this really hard question. The really hard question is, you got work coming into this chip. How do you farm the work to the right chip? Right? Out of the gate, what's the solution? Right? And so that's when I suddenly saw all the work, yeah? That's the work, I suddenly saw all the work that Robin had been doing on bigraphs, which was a way to integrate against a bunch of different process calculi, makes sense in terms of the hardware. Why? Because you can take an ambient calculus, which is all about essentially getting you to the right membrane. So you build up a tree structure on top of this, right? So you have membranes that maybe cover this much of the surface, and a membrane that covers that much of the surface, right? And so you have an ambient calculus that gets you to the right membrane, and then within that membrane you find your right workload, and now you do your work, right? So you combine an ambient calculus with a pi calculus in this way, and that now gives us this ability to have a calculus that reasons end to end on a system like this. But it's a composite widget. How do you, this ends up opening all kinds of wonderful, rich research questions, which I won't go into because we have 10 minutes left. But this is our ultimate target. It costs a bunch of money, right? We can't, yeah.
Well, you had just mentioned there were at least.
You just mentioned that there were at least 3 computation models. There's also the desire for things like arithmetic expressions that are a total functional language.
Yeah,
so there's
absolutely.
a 4th, right?
So we got the functional computational model just hanging out there. And in fact, everyone who's doing dev at this level, right, is thinking functionally. So we've also got that ball up in the air as well. And that's the other reason why we're having these developer retreats, is to get people, to be able to keep all those balls in the air. Okay, so actually, that was probably a fire hose of information. Yeah? Why don't we give ourselves a 10-minute transition to the next thing? But I'll. Oh, okay. But so before then, let me ask if there are any other questions. Yeah.
So having worked in on the thing itself, I agree with your list of stuff here, right? But as for developing a diagram of the architecture that you could put in a slide deck and something like that, I think there's still quite a bit of work to do.
Oh,
right?
yeah, absolutely, absolutely.
So if that were the point of this
thing,
I don't think we're quite there.
No, that's not the point. In fact, one of the things I wanted to mention is that so there are other components that have to run in this container, right? Well, we're trying to get them.
Right, beyond fleshing out, say, what ends up in the JVM that was developed in Scala that's used by Rosette.
Yes.
On which the system contracts run, on which the user contracts run,
right,
and how the object capabilities thread through that, if that's a first-class citizen in the architecture diagram, right, forms a different picture than what we've got here.
Yes, that's correct.
Okay.
That's correct.
So that was my original objection to doing it this way, was that we weren't going to come up with something that everybody could explain to someone else as in terms of this is the architecture of our stuff, because this is our strategy for building a thing, which is different.
Understood.
Right? Okay.
Understood. Absolutely. What we're trying to do is to get in some ways, I keep wanting to argue, start from your worldview and drive your architecture that way. And if you genuinely understand this worldview, you'll understand how this worldview maps to consensus, right? What it means in terms of races, what it means in terms of the consensus algorithms. You'll understand what this worldview means in terms of the underlying implementation, i.e. the actor model and the tuple spaces, right? And everything else will be driven out that way. If you understand this, then you understand exactly how object capabilities maps onto this worldview, right? So in terms of keeping the total number of balls in the air to a minimum, get this ball in the air, right?
Right, and then approached from the other direction, some engineer who wants to develop an RChain node in Rust, Go, something like that, is going to not start with, okay, JVM, Scala.
Correct.
Take the first thing that's fundamental, which maybe is the RBL bytecode interpreter.
That's right.
Implement that directly.
That's correct. That's exactly right.
Okay.
Yeah, that's right.
So at the end of this week, I'd like to come out with, for myself at least, a coherent picture of what the essential parts of the architecture are.
Yeah. Okay. Understood. Absolutely. The other piece of the puzzle is that inside this container, alongside of the JVM, you have whatever you need in order to do comms brokering, and you have whatever you need in order to do storage. Ideally, all of this fits inside one process, but it doesn't always work out that way. Like, it's a lot. If you have a broker, sometimes it's better to stand it up separately. If you have for example, if we were to use a different storage than Lightning, like Mongo, right? Then you'd have another process sitting inside that container as well. And those should be acceptable alternatives as implementations of the architecture. Right? So these are pieces, and then they get made available to the system contracts as ports, which is what this was all about here. Okay, does that make sense? All right. Yes.
In the spirit of getting the worldview correct, I just wanted to focus on one line in the pi calculus specification, the input line with the bang there. And I just wanted to confirm that the X on the left side of...
This is output.
Oh, I'm sorry. Okay, sorry. The X on the left side of the bang is the same as the parameterized X on the right side. Is that correct?
Yes, it is that same X.
Okay, just wanted to be sure.
So now it's all nice, clean, and only in terms of the symbols on the page. Yeah.
Got it. Okay, thank you.
Any other questions? Awesome. Well, let's take a break and get back at it.